questions, you can put up your hand. So this is somebody's math problem. We don't have the diagram. This student did it on a separate piece of paper. What I love about this is that it is super clear. It could be a little bit clearer because I don't know exactly what this is here, but I can assume that what the student has done is they've sort of, this is the first row, the second row, third row, fourth row, fifth row, sixth row, seventh row, and there's a lot of really good calculations here, and it's clear. And what I really like about this is they put the units. Okay, the units are clear here. I know what it is. It's not 680. Some people put 680. 680 what? Blocks? Fish? Cows? What are we talking about? Now, the other thing I thought about this, I thought that this one here, this solution, this student solution, I thought was really, really good. I thought this one was kind of, if we were going to put this on a report card, this one would be exceeding expectations. Because they found a kind of a real-world application. I asked you at the beginning, what is the problem? And this person made the problem, how much would it cost to build this? And so this student says, and it says down here, if we look at this, it says down here that each block, costs $1 or $125. And the student has that indicated down here. And then they've gone and figured this out. Now, the only thing I don't like about this is that they should have, when they were done, they should have put units. And down here, you can't see because it's below the picture, the student put that the total cost would be $85,000. And so the units are there. It's really clear. It's efficient. It's accurate. It shows their thinking. And bonus, it shows a real-world application that this student is thinking beyond just the page, beyond just the problem, and sort of thinking, okay, if this was a real world and I was really using math here, what would I do? So this is a fantastic solution. Let me couple others that are really good too, for different reasons, but didn't quite get us where we want to go. So this one was really interesting, and I pulled this one out because about 5 students did this. What they did in the diagram, now, what this student did was kind of interesting, because what this student did is they counted in the pyramid, they counted the one row, and then they figured that, you know what, there's 4 sides to this thing. I'm going to multiply whatever this is here, I'm going to multiply it by 4. So there was, in one row there was just 1, but interesting that the student didn't multiply the 1 by 4. But the one that had 3 multiplied by 4, multiplied by 5 by 4. And what is interesting here is there's no order to the pattern. Their pattern here is kind of confusing. Now, they've corrected that a little bit by showing a table down here. But I guess these are the levels. Yeah, okay, these are the levels. So 1, 2, 3, 4, 5, 6, 7. And then the numbers kind of go across here. All right? Now, what's interesting is if you start to multiply some of these things, it doesn't really, like, I don't know where the 8 came from. All right, I don't know where the 16 came from because there's no row with 4. There's no row with 2. So I'm not sure where any of these numbers came from. So there's a problem here with understanding. The thinking is clear, but there's a problem with the understanding. And I think what happened, and I drew a little diagram here, and you can see it. The student has figured out that, okay, there was 3 across. So if I multiply the 3 because there's 1, 2, 3, 4, then I'm going to get the number in the middle. And that's not how area works. Area is always length times width. The reason we use the term squared, we say 3 squared is 3 times 3. And the reason for that is that in any square, trying to figure out the area, you would do 3 times 3, not 3 times 4. 3 times 4 is going to get you 12, but if you count the blocks in here, you can see that there's only 9. So there's a problem here with accuracy of calculations, and there's a little bit of a problem with the understanding. So this one, if I was to mark this one, this would be like maybe a 2 out of 5 because there's some big problems with it. Now, what I love about this, though, is the student has made their thinking clear, so I can go and show that student where they went wrong. I go look at one here with the diagram. Is what these students did is they counted how many was in each row. They counted right here, they counted right here, they counted right here. Yes, sir, you got a question?
When they added up on the last one, they shouldn't have multiplied it by 4 because they should add it. If like there's like 15 on the bottom row, you do 15 times 15. And
exactly. So you're right, and I'll show you on this one. So here's another student. I liked this one. This one was really, really good. They had the final answer here, although what I need you to do is I need you to sort of say, okay, so here's the question that they're answering, but you need to make this final answer clear. I need to know exactly where the answer is. I like that they got units. I like that they've got an answer, but I had to sort of search around for it. I shouldn't have to search. Make it clear. I like the table. The table shows the thinking. It has all together. There's some good calculations in here. This student also must have been talking to the other student because this student also went in there and said, okay, well, I'm going to put a price on these and have a real-world application. But then they had this solution down here, 85,000. But the problem here is
looks like they pretty much copied them.
Well, they might have, or who knows? Maybe the other person copied this person. The problem here with their answer, though, is that they didn't tell me that that's their final answer anywhere. And okay, here's their question here. They put every block costs this. How many blocks? How much will all the blocks cost? Okay, but they didn't have a final answer. The other thing I like about this one here is they try to explain what the pattern rule was. So again, this is pretty good. This is like 5 out of 5. Although I'd put a big question mark on it because you need to make clear your answer. All right, last one here. This one.
Good morning, R.C. Garnet.
This one here. I like this one because the table is really, really clear. So good table, showing the layers, showing the total. Not sure how they got the totals, but that's okay. I'm assuming here because 81 is 9 times 9, and 121 is 11 times 11. So I'm assuming that's what they did. So the calculations aren't totally clear. I like that they made it really clear what the total is. Check that out. It's like total. All right. I mean, they could have maybe colored that in purple, and that would have been better. But this is pretty good. But I want to know, how did you get this total? How did you get the total? And the other thing, I asked you what is the problem. You didn't tell me what question you're answering. So these are 4 examples of different solutions done slightly different ways. All varying degrees of excellence, but all with some varying degrees of some flaws that we want to get out of our solutions that we write and we create.